Today we are going to learn about optimized CSV reading with Pandas. We will explore techniques for efficiently reading large CSV files, crucial for data analysts dealing with performance issues in big data processing. Welcome to this video on optimized CSV reading with Pandas. Today, we're diving into the world of data analysis, where handling large datasets is a common challenge. In these scenarios, reading CSV files efficiently becomes crucial. Pandas, a powerful Python library, offers several techniques to optimize this process. We'll be exploring these techniques, focusing on performance issues encountered in big data processing. By the end of this video, you'll have a toolkit of strategies to read large CSV files efficiently, enhancing your data analysis capabilities.
When dealing with large datasets, the performance of CSV reading can become a bottleneck in your data processing pipeline. Common issues include memory constraints, where the entire dataset may not fit into memory, and processing time challenges, as reading operations can be time-consuming. The default settings in Pandas, while convenient, may not be optimized for handling large files. Understanding these performance issues is the first step towards optimization. By recognizing the limitations and inefficiencies in the default approach, you can begin to implement strategies that will significantly improve your data processing efficiency.
One of the most effective ways to manage memory when reading large CSV files is by using the Chunksize parameter in Pandas. The Chunksize option allows you to read the file in smaller, more manageable pieces, rather than loading the entire dataset into memory at once. This can significantly reduce memory usage and prevent your system from crashing due to memory overload. By iterating over the data in chunks, you can process each piece individually, applying transformations or analyses as needed. This method not only helps with memory management but can also improve processing speed by allowing you to focus on one segment of the data at a time. For instance, using the command pd.read_csv large_file.csv, chunksize equals 1000, reads the file in chunks of 1000 rows at a time, making it much more efficient to handle.
Another technique to optimize CSV reading with Pandas is selecting only the columns you need for your analysis. When dealing with large datasets, not every column may be relevant to your specific analysis. By specifying the columns you wish to read, you can reduce the data load significantly. This not only speeds up the reading process but also makes subsequent data manipulation more efficient. For example, you can use the syntax pd.read_csv large_file.csv, usicalls equals column 1, column 2, to load only column 1 and column 2. This approach is particularly beneficial when you're looking to perform targeted analyses on specific parts of your dataset.
Specifying data types, Dtype, for your columns when reading a CSV file can have a significant impact on memory usage. By default, Pandas attempts to infer data types, which may result in larger than necessary memory consumption. By explicitly defining the dtype for each column, you can ensure that the data is stored in the most efficient format. For example, if you know a column contains only integers, you can specify it as int32 instead of the default int64, reducing the memory footprint. Using the command pd.read_csv large_file.csv, dtype equals column 1, int32, column 2, float32, customizes the data types, optimizing both memory usage and processing efficiency. This technique is particularly useful when dealing with datasets containing millions of rows, where even small optimizations in data type storage can lead to substantial memory savings. The Nrows parameter in Pandas is an excellent tool for quickly peeking at a dataset without loading the entire file into memory. This option allows you to specify the number of rows you want to read initially, which is particularly useful for data inspection and exploratory analysis. For instance, using pd.read_csv large_file.csv, Nrows equals 100, will load only the first 100 rows, enabling you to get a sense of the data structure and contents quickly. This initial peek can help you make informed decisions about further data processing steps, such as which columns to select or how to handle missing values. The Nrows parameter is a handy tool for data analysts who need to assess datasets efficiently before diving into more extensive data manipulations. One of the lesser-known yet powerful features of Pandas is its ability to read compressed CSV files directly. Compression protocols like zip, bz2, zip, and xz are supported, providing significant storage savings and faster data transfer times. By leveraging these protocols, you can reduce the size of your datasets on disk, which can be particularly beneficial when dealing with storage limitations. For example, using pd.read_csv large_file.csv.gs, compression equals xzip, allows you to read a xzip compressed file without the need for manual decompression. This approach not only saves storage space but also speeds up the reading process, as compressed files can be read faster than their uncompressed counterparts. Utilizing compression protocols is an effective strategy for optimizing both storage and processing speed in data-intensive environments.
The skipRows parameter in Pandas is a versatile tool for focusing on specific sections of a dataset while ignoring others. This parameter allows you to skip a specified number of rows at the beginning of a file or a list of row indices, which can be particularly useful when dealing with datasets that include unwanted header information or notes. For instance, if you need to analyze data starting from the 101st row, you can use pd.read_csv large_file.csv, skiprows equals 100. This method is efficient in scenarios where you need to concentrate on a particular subset of your data, bypassing irrelevant or redundant information. By implementing skiprows, you can streamline your data analysis process, ensuring that your focus remains on the most pertinent parts of your dataset. Profiling the performance of your CSV reading operations is essential for identifying bottlenecks and optimizing efficiency. The Timite module in Python is a valuable tool for measuring the execution time of your code, allowing you to pinpoint slow operations. By wrapping your read_CSV function with Timite, you can determine the precise time taken to read your dataset, helping you make informed decisions about potential optimizations. Additionally, assessing memory usage is crucial for understanding the impact of your data processing on system resources. Tools like Memory_Profiler can provide insights into memory consumption, highlighting areas where you can implement improvements. By profiling both time and memory usage, you can ensure that your data processing pipeline is as efficient as possible, maximizing performance and minimizing resource consumption. In conclusion, optimizing CSV reading with Pandas is a crucial skill for any data analyst working with large datasets. Today, we've explored a variety of techniques, from using Chunksize for memory management to leveraging compression protocols and profiling performance with Timite. These strategies not only enhance data processing efficiency but also empower you to handle big data challenges with confidence. Remember, the key to mastering these techniques is practice. As you apply these methods to your own datasets, you'll gain a deeper understanding of their benefits and how they can streamline your data analysis workflow. To continue your learning journey, consider exploring additional resources and tutorials on Pandas and big data processing. Thank you for joining us in this exploration of optimized CSV reading with Pandas.